Good morning, young scholars! Thank you for viewing our math video. I wonder where John Luis is.
Yeah, where is he?
Yeah?
Scholars. Time to learn about radians and all they entail. Circles, one of the most key geometric features of our world. Time to learn more in a different way. Let's go look at them. A radian is an angle unit determined by the arc length divided by the radius. Arc length, you got like your arc length right here. You got your radius right here. Think of this line going from the center of this bicycle wheel out to the circumference as the radius. Now think of this radius is determined by this arc length, a determined arc length divided by it. Any circle is made of 6 radians with a little left over. So think of this bicycle wheel. If you split up the spokes, so let's just say this is a section, and this is a section, and this is a section. If we have 6 sections here, there would be a little bit left over if all of the sections were 1 radian in arc length. So they all add up to 2 pi radians, which pi is 3.14. And since each radian is 1, 3, and then that little bit, which is 0.28 radian left over, which makes a pi, but with a little dumb slice. You may be asking yourself, why do I need to know what radians are if I already know what degrees are? A circle is 360 degrees, and everyone knows that. But there's a different way to look at it. A radian is more accurate and changes the perspective of looking at a circle. A degree is basically you are at the center and you're saying how much it is traveling around. So if a car was driving around in a circle and you're standing in the middle and you went to go ask the driver how many miles did he go, degrees is like saying how many times did I turn my head around in the middle compared to how many times it goes around on the outside. A radian is just the distance on the outside of a circle. That's what makes it much more accurate and efficient for higher level math, even though degrees might be simpler to understand in everyday use. If you're making a chair or something and you have a bracket, put that bracket at half pi radian. Like, who knows what that is, but you would say 90 degrees. Each one has its place and each is needed, but radians is another way to look at it that is used in more advanced methods and different types of
terminal angles.
Look at the size of it.
Called a rare fidget spinner. These hold coterminal angles. Coterminal angles are angles that share the same initial side, which is the side on the positive x-axis, and share a common terminal side. When talking in terms of degrees, in order to determine what coterminal angles are, you add or subtract 360 degrees. When talking about terms of radians, you add or subtract 2 pi. Okay, so for an example of coterminal angles, say this is right here, quadrant one, if we have an angle of about 45 degrees and we wanted to find the positive coterminal angle, we'd add 360. So we'd do one revolution, and that would be 360 plus 45, which would be 405 degrees. And then if we're talking in terms of radian, it would be pi over 3, which is a 60-degree angle. And we add 2 pi, which would equal 7 pi over 3.
So, you're here to find out what arc lengths and sector are? Well, you've come to the right place. See, recall that arc length and circumference are very interconnected. The circumference is 2 pi r, and therefore the arc length is just a portion of that circumference. Let's say you're dealing with a sector of a pie that looks just like this. You want to have to find the central angle, and then you're going to take that. Let's say the central angle is about 75 degrees, or 80 degrees. If you take 80 degrees, and then you subtract 360 from 80 degrees, I mean you subtract 80 from 360, you get 280. And once you have 280, you do 280 over 300. That would be the sector that is not remaining. But in order to find the arc length, you do 80 over 360 times 2 pi r, which would be the entire circumference. Since you're only finding a fraction of the circumference, that means you use 80 over 360. Now, in order to find the whole area of the sector, you have to use the area formula, which is pi r squared, compared to the circumference formula, which is 2 pi r. So for the area of a sector, you use the area formula. Now what you have to do with that is almost the same thing as you do for the arc length. You have to use a fraction of the entire area. So you would do 80 over 360 times 2 pi r. Let's say the radius is 5. You do 5 squared, which is 25, times 80 over 360 pi. And that would give you your final answer. So that's how you calculate arc lengths and areas of a sector. It's basically like a slice of a pie. On this segment of our video, we're going to be explaining angular speed versus linear speed. You see, linear speed and angular speed are interconnected, but they're very different. Angular speed is at angles, while linear is on a straight path. It's recorded in time over distance. So, for example, if you were to hold this plate on the ground, the linear speed would be the distance from here to here as tracked by the circumference. In other words, linear speed is just a distance in a straight path. Very similar, but at the same time very different from angular speed. Now my friend John here will explain angular speed in more details.
Yeah.
Let's go to angular velocity and angular speed. So, if linear speed is the circumference, angular speed would be the inside angle turning the entire time. You see, angular speed is the same no matter what the object or how big it is. It's a matter of just 2 pi radians, you see? So it always takes 2 pi radians to go around, which would be the angular velocity of an object. Therefore, it's always the same. Angular speed results from a circular motion made by an angle at a given point in a given time. Therefore, angular rotation is a rotation in unit per time.